again. Inulo, did you? Okay, maybe it's from before. So welcome everyone to class 8 of hands-on machine learning.
Hello?
You ready? Yes,
Hello, Tolulokwe, sorry. You just started the recording, right? And
yes,
the
I did.
beginning part of the class was actually very important to someone like me because the questions she asked were relevant to me, right? And I happen to be at an event. So when I go back and watch it, that means I'm going to miss the answers that you gave for those
Okay,
things that she asked in terms of installation.
no, no problem, no problem. I'll tell her to ask it again and I'll answer it again at the end of the class.
Sorry?
I'm going to tell her to ask it again and I'll answer it again.
Okay, thank you. All right,
Yeah.
thanks. Yeah.
Deborah, do you still have the list of your questions?
Yeah, the first question I asked
No,
was,
no, 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 not now, not now. We'll go over it again. Yeah. So thank you very much for coming to today's class. I need someone volunteer timekeeper. Joy. Joy, please let us know. Continue. Joy, please let us know when it is 15 minutes to the end of the class. That's 1:45. 15 minutes to the end of the class. Yes. So welcome to today's class. Today's class is going to go in this way. We're going to go do a quick recap. There are some things I need to touch on so you can see it's going to be very basic but also very important. So it follows the same thing. If you have any questions, come on the chat, raise up your hand. If you ask the question, if it's too long, I will wait till the end of the class, but if it is immediate, straight, I'll hit the nail on the head. So lecture 6 and 7 recap. What we did a little of Python. And when we did a little of Python, we looked at different functions, string manipulation. We looked at data structures, lists, and the likes. Then went to pandas. We saw different pandas, how to read from a file, how to use Google Colab, how to check the head, describe properties, inspect, and see that your files are good. And at the end, we tried wine quality. And then we were able to read, describe, check different variables and stuff. Please, I hope personally you are working on this and you are making sure you are at least committed, because I was on the classroom page. I was expecting, hey, Big T, Tolu, Pataki boy, what's up? What's going on? I'm having this issue. Can we just link up? Can we do a Zoom call or something? I was expecting stuff like that, but it's just quiet. And it's not like I don't like quietness. I like it, but I assume everybody's, super smart and stuff like that. So we did correlation and we did all those things, right? So when we were done, what did we do? We trained with sklearn. We trained with what? sklearn. And sklearn outputted these values. We checked the difference between MSE, RMSE, MAE, different metrics to measure our regression model, to see if our regression model is good or is bad. And then we tested them. I'm going to copy this. Let you see. No. I'm going to. Yes, I'm going to copy from here to here. You'll see why now. Now, we want to gradually transition to TensorFlow. Now, this regression issue can also be solved with TensorFlow, but it's like taking a gun to a hammer fight, or a gun to a. Many in at work, I use TensorFlow for regression, right? But but before I use TensorFlow for regression, I first use sklearn. In sklearn, I try linear regression, polynomial regression. I try all those things. I try XGBoost. I try different algorithms. Before sklearn, actually, I tried AutoML. Maybe next class I'll teach you AutoML. AutoML show me that your model will be good with this data you have, or you still need some model cleaning. And then I go to sklearn. If sklearn shows me something good, I'll go to TensorFlow. Right? So it's just to test different models and see that I'm getting the best on product. So now, to do the same thing, that we have done on TensorFlow. So if you look at just here is sklearn. We used sklearn here, and this is where we tested the model. So I want to do the same thing with TensorFlow. All I did was model.tensorflow. I imported the TensorFlow library, just where I imported the sklearn and NumPy libraries. I created a sequential model. A sequential model means that it is static, right? It is static. It's how what you give it. It's not dynamically changing anything. So usually most models are sequential. This is just the default. Now the input layer, if you look at, I create so model.tensorflow model.layers.input. Input shape is 11. Why is it 11? Why is it 11? It's 11 because the number of features I have right here is 11, aside the one I want to qualify. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Aside the one I want to qualify. So there are 12 columns, but 11 features. That is why it is 11 right here. Or if you want to use, no, let's make it more complex. I was saying that you can also, instead of 11, you can say, for those that practice Python, you can say, features is now a list. Length of features, which is going to be 11 minus 1, right? So now, we created a layer. The layer architecture is, so we created a dense layer. Dense layer is just fully connected layer. Mr. Israel touched on that during the intuition part. We created just dense layers, dropout layer, which we will touch, dense layer, dense layer, dense layer, dense layer. We used optimizer of Adam. There are different optimizers. I think the new one is Lion. There's a Lion optimizer too. We will touch on it. I'm just showing you that TensorFlow can be used for regression. And then we compiled and we trained. At the time when we trained finished, we noticed that if you look at the losses kept reducing, right? The MAE got to a place where it was 1. Got to a place where it was 1, and then we plotted how the loss was reducing. Right now, you can see that sklearn model is better because sklearn model gave me an MAE of 0.51. Let me show you just a recap. An MAE gave me a model of 0.51, while TensorFlow is giving me 1. So common sense tells me that I'll use the one for sklearn. Make sense? Makes sense. Recap of what I just said. We have seen regression. We have used 2 weeks to study regression, and so far we have used sklearn to do regression. So all those data processing that we did, the way I inserted it into an sklearn model, I just picked it again. If you see, I copied this part. It's the same thing with sklearn, right? The splitting into test and train, the using a normalizer to normalize the data, and those values. If you see xtrain, I just brought it down here. That create a TensorFlow model. That's the way I created an sklearn model of these parameters. Now I can take them out. I can take these 2 out and still train. I just reduce the model. It will still train. And I'll compare accuracies across the models. It will still train. So it's not necessary that what I have here is set in stone. It's not necessary. Now, what are the meaning of these variables? How does TensorFlow know all this? If I want to do TensorFlow, do I know the meaning of this? I want to teach you that in another lesson, so I will use 1 stone to kill 2 birds, which is what? Classification. Now, before we go, last week, we were supposed to touch on another data set, which is heart disease. So I'll come here, upload.
Sorry to interject you. There's a hand that's raised.
Oh, June. Sorry, I was in the spirit. June, please.
No, sorry, I've already said something, so let me take it down.
Okay. So now, I have the heart disease again. So this was just a way to reinforce what was already taught, which is the same thing I did in the previous in the previous thing, which is what I read the data, I read the file. When I read the file, I saw the head. I checked the length of the file. Yes, this was to teach when I have missing data. So if you look at the length of the file is 4238. But when I go to the describe, male is 4238, 4238. That means that male is perfect. Age is 4238, but education is 4133. So some aspect of education is missing. Smoker is 4238. Cigar per day or cigarettes per day is cigar. Jesus. It's 4209, but 4238 is still there. You understand? So it's showing me places or columns or features where there are missing data. I wanted us to tackle this yesterday. So 4238, 4238. So now, based on this, I already know that there are some missing data, but let me verify. Let me check. Are there, so this is to ask, across all the columns, across all the tables, are there missing values? It's saying it is true, there are missing values. Okay. And now, if you notice, every step I did for the wine quality on is the same thing I'm doing again. I now checked, okay, you know what? I want to convert the features to a list, which I did to a list, right? So how many features do I have? I'm sorry that I'm moving too fast. The essence of this heart disease project is to predict that in 10 years, would they have heart disease? In 10 years, will they have heart disease? So this is what we're trying to predict. So using their glucose, heart rate, BMI, I don't know, systolic and diastolic. People, whoever has medicine background, I'm assuming the total cholesterol, diabetes, if they are hypertensive, prevalent hypertension, prevalent stroke, if they use BP medicine, cigarettes per day, if they're a current smoker, education, age, and male. So that's what we are trying to predict. In 10 years, would these people, based on their state now, would they have heart disease? So now we've noticed they are missing data. We look at the features. Now, the features does not include what we want to classify, just the same way quality was removed. So how many features are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, I want you to notice one thing. Look at education. Okay, sorry. Where is it? Look at education. Education is 42133. What does that mean? In machine learning, we try to make anything. So education is supposed to be undergrad, school SAT, high school, PhD, MSc, PGD, anything like that, right? We try to encode whatever we mean in words into numbers. So yeah, one may mean, we don't know. This is the data they just gave us. One may mean that, it only has primary education. 2 may mean secondary education. 3 may mean, but from the describe, we know that education, the highest value is what? 4. The lowest value is what? 1. So it is between 1, 2, 3, 4. That's the range of value. So let's say 4 is postgraduate, 3 is graduate, 2 is maybe professional certificate, 1 is high school. Maybe that's what they mean. But all those letters are represented in numbers, right? That's one thing I wanted to share with you. Now, I already know that there's a missing value across the data set. Now, I want to know which one of them is missing. I know that education has a missing value. I know that six per day has a missing value. This is just to reinforce what I got from describe. This is just another way to do it. Now, I want to plot all the data together. Age is going to be scattered abroad because it covers a wide range of people, boys from 70 to about 33, 34. To find out this value, you just come to the describe. Where is age? The lowest value is 32. The highest value is what? 70. The average value is 49. Oh, sorry. Yeah, 49. So now, 6 per day. Some people, they smoke 70 cigarettes per day, Some people 60, some people from 0, right? I want to check the correlation. So this is basically showing what we did. So what do I do in this scenario? When I wanted to train, what I did was I just dropped all the missing values. Because why? All the values that are missing, that means that if I look at the describe, I will see that there are about, the total number of data I can pick is 4,185, right? So around that, it will still be about 4,000. So that means that I'm losing less than 10% of the data. So that's fine with me. Do you understand? Does that mean that if we have them as strings, we need to first encode them? Inulua, you are very correct. Yes, we need to encode them, but it depends. So we are supposed to look at a situation where we need to encode, right? But we'll chunk it up to, what we will review. Yes, we need to, Inulua, you are very correct. Yes, so the same way what I did was I dropped all null values, and then the same way I did my test train splits, I did my random state to 42. You can use any number, and then boom, voila, I got that this thing can predict with an error of 0.35, right? And yeah, what I did here is I used a linear model to predict. Yeah, I used linear regression. I use logistic regression also to emphasize that you can switch between models in sklearn. Please, any questions? Hello. So far, do you mean that you dropped all the rows with missing values or data? Yes, all the rows. It's not just those data points. All the rows that don't have all the 15 properties, I dropped all of them. Because at the time, let me see. I've not dropped it. Okay, let me drop it. So after dropping it, let me come here. After dropping it, I have 3,656 rows left. So that means that the rows, some rows have some ones, it's scattered about. It's not the same row that have missing values. It's scattered about. So all those values, because I can't just guess someone's age, right? If age is missing, I can't just guess someone's education. I can't say the mean of this education and this mean of the education, because those values are independent and different human beings. Those, assuming that the rows are about 30 to 50%, is it okay to continue the training or return the data for necessary adjustments? So as a machine learning engineer, is a rule of thumb, don't go back and say I cannot do my job because data is not complete. Don't go back and say, as a rule of thumb, don't go back and say you cannot. This is going to translate to the next thing I would say. If they give you 2 data sets, okay, they can't give you 2 data sets, right? That one, return it. Now, if out of 4,200, only 600 rows are gone, you are good. Now, out of 4,200, if I have 2,000, I'm going to give them this is one of the issues I'm actually even facing at work. I'm going to give them a model and say, based on these data sets, this is how the model is performing. With more data, my model will definitely be better. You understand? So this is where you now tell them that, please, you need to acquire data because there's a reason why you're not getting data. Now, hey, can your data set be realigned? So now, the next question, which is the question I've been asking for you people to ask. What if you have 1 million pictures? Yes, we asked last week. We said PCA. So let's assume that some data are missing. Can I drop those features and leave the 4238? Can I drop them? Can I remove them? That irrespective, these features are not complete though. But out of 15 features, 3 are not complete. If I remove them, how will it affect the model? Okay, maybe this one has the highest number of missing features. Let me just take that one out and also cut the missing value. So instead of 600, it's now maybe 400 I'm removing. or 300. All these compromises are what we do to get the best model, right? So now, so all this is using linear regression, just showing different models. You can change linear regression, you can do polynomial regression, you can do as much algorithm. I sent you a list of all the sklearn classifiers, k-nearest neighbor, Gaussian, subject vector machine. You can just try all of them and see how they perform on the model. Good. So now, the length of the features are 16. What if it was 1 million? What do we do? Last week, Joy gave an answer and said principal component analysis, which is which component, which feature is the biggest, contributing the best relationship that the model is looking at. Do you understand what I'm saying? So say, for example, in a home, if your elder brother say, go and wash my clothes, and your daddy or your father say, go and wash the car, both of them can beat you. Both of them can slap you. Which one will you do first? You're going to do, I'm assuming, you're going to do what your, father said to you, or whoever is the head of the family. If it's your uncle that is giving you the most money, you will sharply go and do it, right? Everybody has a stakeholder. So who is the principal person in order of hierarchy? So in some family, it is father, mother, or customarily elder brother, elder sister, uncle and auntie. Yeah. Yeah, exactly. The father can. Good. Now, these principal components will go through the 16 of them, or we'll go through all the features and say that, what are the best two? You can even say what are the best 2 features, what are the best 3 features, what are the best 4 features, instead of the 16 features. And then we do one component analysis. It's telling us that this is just the syntax. You can change it. So I want number of components. You can do up to length of the features. You can do up to 16. You can do up to 16 because the number of features is 16. You can do up to 16 component analysis. Oof, sorry, 15. And do up to 15. But it used to confuse me. I just used to do 1. And I'm going to surrender that. You people should go and read. Right? So I used to do only 1. Now, what does that 1 mean? 1 will make us understand what it means, right? Now, when I do this one, this is the weight it is attaching to each property. This is the weight it's attaching to each property. So it's saying male, 0. That's the sex of the person. It's attaching, ignore the negative value. Is it that positive, forward or downwards? It's saying that this is 0.0008. Me, I used to look at, this is just me personally. There are some other people that are very detail oriented, more than I am. Yeah, very detail oriented, that will go and read what is what. Me, I'm not that detail oriented. And if you do it, please come and teach us. Now, what I will do is that I'll count the number of zeros. The ones that have the highest number of zeros, I will ignore them. So, like in this one has 3 zeros. This one has 1. This one has 3. This one has 3. This one has 1, 3. This one has 4, 2, 3. This one does not. So no, sorry. The meaning of 0 is after the decimal point. So this one has 3 zeros, 3 zeros, 3 zeros, 1 0, 3 zeros. So what if all the ones that have 3 zeros, let me ignore them, let me throw them away, right? So that means that I will take the sex of the person. It doesn't matter your age. You can have a disease anytime. It doesn't matter your education. If you're eating anything, you can have heart disease. It doesn't matter if you're a current smoker or not. What matters is the amount of cigarette per day, right? Your BP meds, doesn't matter. So I took all the 3 zeros out and I now inserted it again. So now I did what? Feature elimination. I took them out and I trained it again. This is what I got after removing some features. My MSC was 0.16, 0.4. Let's compare it to when I use the full features. MSc is 0.16. With the full features, MSc is what? 0.16. With logistics, with linear regression, 0.13. Okay. So they are comparable, aren't they? They are. Root mean squared is 0.4, should be 0.4 and 0.35. Okay. MAE is 0.16, MAE is 0.16, MAE is 0.24. And please, between MAE and RMSC and MSC, which one is most important? Whoever gets it, well, let me that. Someone should unmute and say it. MAE, MSC, RMSC, which one is most important? MAE, someone has said it. Deborah, yes. So in this scenario, I did not say I'll give you money, but good job, good job. Deborah really studied though. There's evidence that Deborah is studying. So now, based on that, I will, because the difference between, where is it, after the feature elimination? Yes. So after the feature elimination, I would obviously pick this one that has little features. Do you understand? Olumide. No, Olumide. Okay. So now, I will confidently say, okay. So now, so do you understand? Now, what if, so if you see, I now tried another thing again. I was trying to push my luck. So this is age, 6 per day, total cholesterol, sees this, I think it's the same thing I used. I just used it again with, so this one, I used logistic regression. He gave me this, and I used linear regression. With linear regression, we can see that the model 0.25, but I'll choose logistic regression because the MSCs are very close. The RMSCs are very close, but the MA is now better. So I will pick logistic regression. So now, then I was trying to do something on recursive feature elimination. Is another way, is an alternative way to PCA, but let's just move to something. So this is the end of lecture 6 and 7. It's now in your hands. You know, I've given you the tools, legit tools. You do this and you take 2, 3, 4, 5 data sets from Kaggle. Apply to any job. If they don't pick you, call my name. They don't pick you, say that you understand. All I'm just trying to emphasize is it is practice. It is practice. You know, I remember back in school, even though they gave us the assignments, a bunch of us created like a group where on specific days in the week we'll just meet in the lab, we'll just be picking questions and be solving it. And I will tell you, aside from all the things we read in the book, all the papers and publications I have, that is one of the things that has made me and who I am today. You just need to practice. The more you practice, the more confident you are, the more things you feel you can approach, and everything. So please practice. So that's question 6 and 7. Let's go to 8. 8 is way wow. Are you excited? 8 is what? Wow. So we've done this. So 8 is on convolution neural networks. Convolution neural networks. Now, if you see the sequence of the way they teach us, at least using Nigeria education from nursery school, they first teach us numbers, how to identify numbers, and then they teach us ABC, which is strings, right? We've done strings, A, B, C, D, I, T, E, T, T, R. And then they teach us, numbers, 100 times unit, 2 times table, 2 times 1, 2, and the likes, right? Sorry, I know this because I'm a teacher. I used to own a coaching center. So now, the next thing is what? Pictures. This is an elephant. This is a goat. This is a pig. This is whatever. That's how we want to train our model. All these things will, plug in because you are AI is trying to practically create a human being. What am I saying here? Fortunately, unfortunately, I'm in this field. Convolution neural network, aka computer vision. How the computers see pertaining to sight. Just I'm trying to make something analogous, right? CNN, convolution neural networks. Now, these are the links to the data set we'll be using for this exercise. Um, let's see if we can do it in 45 minutes. The links to some useful resources and the links to the notebook that I have here. Now, what is convolution neural network? To me, convolution neural network is a filter, or they call it convnet, is a filter. Now, convolution is trying to mimic brain cells in the brain, where you have different senses. Your eyes reads light signals, and when it reads light signals, your retina takes it and is very close to your brain. Your brain interprets it and tells you either to defend that a slap is coming or to run, a lion is coming. It tells you what to do, and parts of the body or departments of the body know what to do, and then they take off. So how the interaction between the light rays, your retina, and your brain is what we're trying to do from a computer perspective. Now, convnets or convolution neural networks, what they do is they take an input image. From the input image, they analyze the pixels of the image, converting the pictures to numbers. And then when they do the analysis, they try to weigh significant features of the number. Do you understand? Significant features in the pixels, in the values in the pixels. And that is what they will translate to other layers. That's basically what convolution is. It's just like when you're watching a movie and a guy sees a girl that he loves, and every other thing becomes blurry. He's now seeing only that girl. That's how convolution is. But convolution is not biased to it goes both ways. When a girl sees a guy that she loves and it's that guy, it goes both ways. You just see significant features. A cat, this is the eyes of a cat, this is the whiskers, this is the lips, this is airy, this is this, and then boom, it forgets about the background. Now, this is basically what it looks like, right? Look at the convolution. Convolution neural network consists of different layers, different of convolution layer, pooling layer, a flattening layer, a fully connected layer. Do you understand? And then an activation layer. So say, for example, you see a zebra. What's the distinct? And maybe you say horse versus zebra classification. What is the difference between a horse and a zebra? Give it to the convolution. How is it going to look? It's going to read the images. Look at, zebra and horse have the same shape. But some, I'm noticing black in some specific places. What is the color code or the code for black? Black is 0. Wherever there is black is 0. Where is white? It is 1. So you will notice that white is 255, I'm assuming. Black is 0. So you will notice that now the zebra pictures may be dirty, or even the image may be dirty. You will notice that for zebra, it is 0 or close to 0. Maybe 0 to 10, which is black or slightly black. And for the other part on the zebra, it is between 200 or 98 to 255, because that is close to white. So it will just be saying 0 between this bucket. If this bucket is scattered about, it is a what? Zebra. But if it is brown, which can go from reddish brown to any type of brown, stallion, black, completely black, all those kind of things, it is not, because there's no white and black. This is not a zebra. You understand? That's why it will come up with probabilities. If you look towards the end, probabilities of, is he a horse? Is he a... You understand? Maybe this one, they are trying to look for a model to clearly identify between horse, zebra, and dog. So this one will output the probability that what I'm looking at, I am 70% sure that it's a zebra. So this is a more realistic way. Just picture a camera, right? You're looking at a cat. First things first is take the image, you apply convolution layer to it, right? You can apply as much convolution layer to it, as much pooling layer to it, as much dense layer to it, as much flattening layer to it. Now, that will distinguish different machine learning engineers, because all of us will know this. And all of us know it. Let me give you a case in point. At work, when I just started work, right? There was this guy, machine learning is not his background. Machine learning is not his background. We're not very good friends. So all he was after is accuracy. The MSC, imagine someone should be working on it. The MSC is 150 seconds. That is spectacular. Because the RMSC, MAE, very good, was like 1 second. 1 second. Which consumer want to notice 1 second? But you know what he did? He just went to pack convolution layer, dense layer. He went to pack everything. Bam. So he was using, just imagine you want to fetch water, small water. You are carrying big bucket. There's no so they were using close to megabytes of memory for it. This is what will distinguish different machine learning engineers. Some people are just after accuracy. No. So now in this scenario, this is VGG16 architecture. There are a lot of architecture. There's ResNet, CafeNet. So when you know a machine learning engineer, you'll be saying the best architecture. So people like Facebook, Google, and some grad students will work on very good model, and they will post it online that we have this very good model. It is free to use. Everybody can use it. VGG16, CafeNet, ResNet, email. There are a lot of them. So this is VGG16 architecture, right? So back to my story. So when I met him, I said, you are in machine learning. He just watched YouTube, look at Python, and did everything, and then bam, Oshishe. We're excited. All our bosses happy, and they are good. I was like, They now said they are using memory cards. So the time for computation was expensive. By the time I did it, I was like, no, my specialization is tiny machine learning. So I cut off some things, did some quantization, and then boom. My model was in kilobytes, and my memory or latency was about 175 or 200 seconds. The hierarchy of memory I saved. So I didn't even need memory card. My model was faster, and the MA was still about 1 second. So it's like, so pay attention to that. That is just a side story. Welcome to my TED Talk. So basically, in VG16, it takes the image, pass it through convolution layer. So we're going to discuss all these layers. Conv1, Conv2, Conv3, Conv4, those are convolution layers. They're kind of like used for filtering features. So now, let's start with input image, right? An image can be colored or grayscale. An image can be what? Colored or grayscale. Most image that we see are colored, right? Most image we see are colored. So unless an image is in black and white, that is grayscale. So if it is in colored, we have to separate them in channels, which is in RGB or BGR, right? RGB means the red channel, the green channel, and the blue channel. I think those are primary colors or something, right? Or BGR, blue channel, green channel, red channel. Some technologies use BGR, some use RGB. So be careful. For example, we trained a model in RGB, BGR, and someone was doing Android deployment and wanted to deploy it in RGB, and the model predictions was crashing. And that was what held the project down for like 2-3 weeks. Do you understand? So all these things in a tech company, So this is about the input image. So now if it is input image, it will be 3 channels, and that's why you see red, green, blue. Yeah, what's the question, Joy?
You just mentioned RGB versus something else. Another order. What's the difference?
BGR. No. So BGR is just the placement of the layers. So in this one, you can see the red is first, the green is second, the blue is last. That is RGB. Right? In BGR, blue will be first, green will be second, R will be last.
Okay.
Yeah.
Is there a reason why you use one over the other?
It's just the technology. So whatever you use to read the model, right? And you used to do your training. So just know the sequence of your training, because your weight will also go will train based on those layers or based on those channels. So wherever red is, it is expecting red channel. Wherever green is. So if you're going to use BGL to read it on the long run and give green channel to red channel, usually green is always in the middle. You can't give blue channel to blue channel and red channel to blue channel. Your prediction will be wrong because it's expecting red colors. It has associated the pixels of red channels of different images to those weights. But in grayscale is just one channel. You cannot confuse it. I was talking, we were in a brainstorm session some weeks ago. Some people, to train grayscale models, what they do is they will make grayscale models. So this channel, they will make it into 3 of the same image and then pass it into a model like it's a 3-channel thing. I've not tried it before, but it says it makes the model smarter. That's another technique. Now, we now have convolution is made up of layers, right? It's made up of layers. We have convolution layer. Convolution layer it's kind of like a filter. It's a way to collectively merge, different pixels together into one, right? So say, for example, this is 110011001100. It is sure you can pause this thing like this. It is convolved with a weight. It is convolved with a weight. What is the weight? The weight is called kernel. Sorry, hold on. Deborah, you asked a question. How can you differentiate which model is deployed? I don't understand your question.
It was regarding the red, green, blue.
Okay. So what I suggested, because they didn't know what the problem was, take the image, read it in software training, and read it in deployment. When you read it, look at the 3 pixels, because the model is not the problem. It is what is receiving and what is outputting. The model is not the problem. So let's see what is receiving. If we see that it's receiving the same thing, then, and it's outputting something different, then we'll go and look at the model. So by the time they just try the first point of approach, what is it receiving? They see the difference. Like, oh, okay, don't mind them, engineers. So, yes, a convolution layer is a filter. It tries to filter distinct features, important features, Now, before, what people will do, they will go and say that, zebra. A zebra has white stripe, a zebra has black stripes. If you see what, they will now programmatically write it. So feature extraction was very, very rigid. What's the difference between close-up and McLean? Or Golden Moore and Milo? No, Golden Moore and Conflicts. Right? You will now write all those things. The wrapper is blue, Conflicts is smaller, Golden Moore is smaller, Conflicts is bigger. Sorry, it's been a while I saw those 2 things. So stuff like that, right? Now, that's what they do. But this one, with convolution layer, it is automated. It will automatically start some weights, fine-tune the weights, and automatically pick what features are important and what features are not important. That is what convolution does. You understand? Now, convolution layer, one of the problem there is that convolution layer is memory computation intensive. Convolution is computation intensive, right? It's the most computation intensive layer ever, right? So now, what does it entail? It entails interaction between an image or an input and a kernel or a weight. So the yellow box is the kernel. So if you look at it, the kernel is 101, 010, 101. If you multiply this value, if you come here, 1 times 1, let it end. So if you do 1 times 1, 1 times 0, 1 times 1, 1 times 0, 1 times 1, 1 times 0, blah, 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 it will give you 4. So if you do that, it will be 1 times 1 is 1. This is 0, and this is 1. So that's 2. Then this is 0, this is 0, this is 1, that's 3, this is 0, this is 1, this is 0, that's 4. So that's why you will get 4 here. So if you do those dot multiplications, it will give you 4. So that's what convolution is. This is just convolution between one 2D array with one 2D array. All right. So now this is a full-scale convolution. Let's assume that you have an RGB. The RGB is red and is converted into pixels. Now you are now convolving it with a 3x3 kernel. So if you look at, there's something I want you to know. The number of channels of the image is equal to the number of channels of the weight. Every channel will have its own weight. So you can see the red channel has its own red weight. The green channel has its own green weight. The blue channel has its own blue weight. Now, if you do 0, 0, 0 multiplied by -1, -1, it will give you this value. So that's what it's just combining this value and calculating them for you. So this is basically our conversion. It's just a multiplication and addition. Multiply them and add all of them together, and that's what convolution does. So it's a filter. So say, for example, look at all these zeros, right? It's saying that I can combine these 9 points. I can combine these 9 points. Instead of it to be 9, it will be 1 point. So I'm combining all the features, whisker, so whisker, everything into one number. That's the feature. This is into one number. That's the feature. That's what it's saying. So it's shrinking everything from a cat or a lion down to a specific feature. Amen. Amen. That's what convolution does. It filters elements down. Pooling. Pooling is a subsampling layer. I don't like pooling layer. In short, the problem we have in machine learning is pooling layer, but it is important. Pooling layer. What is pooling? Pooling layer is a subsampling layer. It's a layer where you have all these features. I want to pick one, or I want to pick a generality. I want to generalize all of them. That's what it is. So say, for example, all these text I wrote, this is just what it means. So there are two types of pooling: max pooling or average pooling. In max pooling, look at, maybe the pooling window is, the kernel window is 3x3. The kernel window can be 4x4, 5x5, 6x6. It can be any amount depending on your design. Usually people use 3x3. They've noticed that the smaller the kernel, the smaller your loss, because you are just generalizing small features. If you're going to generalize a lot at a time, you might lose a lot of information. What you will cram at that point in time. Just imagine you're trying to cram whisker, picture, air, color. At the same time, you will lose information. Do you understand? Please, can you hold on for me 1 minute? Sorry, I had to attend to something. Yes, so that's the beautiful thing of convolution. So this is pooling. Now, if you look at this pooling window is 2x2, right? And so we have 12, 20, 8, and 12. Max pooling, we just pick the maximum. You see what it did there? We just say that of all these places, so 20 is fine. So 20 is fine. In this place, 34, 70, 112, 100. You just pick what? 112, and that's it. 30, 0, 22, 30, 37. You just pick the maximum. Whereas average pooling will add everything together and divide by 4. So 20 plus 12 is what? 32. 32 plus 8, 40. 40 plus 12, 52. 52 divided by 4, 13. So you just pick. Now, this is the problem with average pooling. 13, is it not close to just one of the property? 12. Maybe 12 is the generalized version of it. No problem. Like this one. This is just what? 8. Instead of 30 is there, 0 is there. You understand? This one, it will pick what? 79. I think this is the most generalized version of it. Sorry, to pick 20 when something close to 40 is there, 37. So you can see these are the two. Now it works. Industry standard. In most of the time, I use max pooling. Why do I use max pooling? I use max pooling because it is less computation. It has less computation. So what that means is that you just look which one is the maximum, take it. In average pooling, you have to add everything together. So addition is there, division is there. All those are computation power. So most times people use max pooling. If you go online and you see tutorials, most times they use max pooling. So pooling is a way to reduce your feature space. No median pooling. No, there's no median pooling, right? Because median is just almost the same thing as max, right? Which is that, what's the middle number? There's no generalization to why you're picking the middle number. So this is just another expression of pooling that, this is max pooling. If you have a 3x3 window, you just pick off those 3x3 window, you just pick, and there's something I did not add to this slide, which I think is important, but let's continue. So now other layers are batch normalization, flattening layer. Those are other layers. Then we have activation functions. Now, let me see. Let me see if it is it's not too small for people to see. Right. Can you see my screen? Is the graph small? So we have sigmoid function, ReLU. These are their formulas. Tanh, and I know Mr. Israel, but there's a wide range between average and max. What can you say about that? So there's a wide range between average and max. Like I said, industry standard. Why I would rather pick max. Max is in this place. So this is the most dominant feature. There's a science to it. This is the most dominant feature. This is the feature I'm holding on to in this place. So this is the most dominant feature. Average can, if the numbers are wide apart, if it is a black background or a black dot on the picture, not even on the image, average will just take everything and then so I rather stick with max, which is, I know that it's only the dominant features in those pixels it is dealing with. So that's why I assume many people stick with max, right? Good. Now I want to quickly do a calculation here. We're good to go. I want to do a calculation here. Now this calculation saved my life. Insert text box. So the calculation is I minus 2p minus k. I like my tweets. I plus k over s plus 1. Sorry, I'm going to explain this formula to you. As an engineer, we should know what it is. You can be asked in an interview. Now, I plus k over s plus 1. I is image size. Usually in machine learning, the image are given square sizes, so it's either 4x4. When you take your picture, it's either 1860 by 1020. Usually in machine learning, will resize it to the same size, 100 by 100, 200 by 200, 225 by 225. Now, image size is I. K is kernel size. So in this place now, let's assume this is my image. This image is 1, 2, 3, 4, 5. So this is 5 by 5. This is 5 by 5. Now, what is the kernel size or the window size? The window size is 3 by 3, right? 3 by 3. How do you know from 5 by 5 and 3 by 3 the size of the output? This is the formula. I minus k over s plus 1. I think it should be I minus k. I minus k over s plus 1. So what does that mean? 5 minus 3 is what? We'll find out if it's plus or minus. 5 minus 3 is what? Is 2. Now, 2. What does this S mean? Sorry. I is image. K is what? Kernel. S, what does it mean? It means stride. It means stride. So if you look at this window is moving. If you see, just look at the start point of this window, right? When it starts from the beginning, here. It moves by one step, and then it goes back to the beginning by one step. In some cases, if you put stride to be 2, it will move, instead of it to start from here, to come and start 2 places. Stride is what? In this scenario, stride is 1. So I minus k over s plus 1 is 5 minus 3 over 1 plus 1. That's going to be what? 2 plus 1, and that's why it is 3 by 3. If you come to this place, they didn't give us the full size, right? They didn't give us the full size. But if we come here, it's also the same formula for convolution. This is 1, 2, 3, 4, 5. 5 by 3 by 3 will be 2. It is I minus k over s plus 1. Now, if it is, we'll get to that. So that's the end of the slide, right? That's the end of the slide. Now let's go. This is very useful. This was very useful for me when I was learning the skill of the trade. This is a course from Harvard. If you can target when they will pick out, because this is a fall semester, they will start a new one. It is free, you can join. It is really good, really good. So it's just showing what convolution mean. We've covered it. We're showing all the layers. You know that maybe you have a car, conv, ReLU, all the layers, right? So a convolution layer is just more information, kind of like what we've done. And then from convolution layer is showing, this is some very good graphics. So now I can pause it here. Yes, I can pause it, unlike that one that is on the page. So now 1, 0, 2. So this is the weight. This is the image. This is the kernel. The kernel is a 3 by 3 kernel, 3 by 3 kernel, and by 3. And these are the outputs. And you can now see, if you check the multiplication, you will see that they all tally as they toggle the movement, right? What this means, there's a concept called padding. That what is S? S is stride. It's called stride. And in this scenario, S is what? In this scenario, who can tell me what S is? S is 2. Can you see why S is 2? Do you know why S is 2? You can see it is starting from 0, index 0, like the first column is starting from the first column, right? When it moves again, see where to go. You can see that the first part did not come to this one at all. It came here. So how many times did it move? It moved from here, 1, 2. That's why stride is 2. So if you want to try that formula, I minus k over s plus 2. This, what's this? 1, 2, 3, 4, 5, 6, 7. I is what? 7. K is 3. 1, 2, 3, right? And the output size is 3. So I minus k, 7 minus 3 is what? 4. What is the stride? The stride is what? 2. 4 divided by 2 is what? 2. 2 plus 1 is 3. That's how they got 3 by 3 by 2. Make sense? So if they come and tell you, when you are doing your interview, you can say, the output of the convolution is going to be this, and bam, I minus k over s plus 1. Bam, 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 bam. Right? And then it talks about, yes, please.
You said that's how they got 3 by 3 by 2. The calculation gave us 3. How else did you determine what are the other numbers?
No, so I told you that the image size will always have the same size. So length by the length, breadth, and depth. So now if you look at this, is 7 by 7 by 3. So to calculate the 7 by 7, which is length by breadth, which will always be the same, 3 by 3 will always be the same, hence 3 by 3 will always be the same. Does that make sense? So if you want to find the third layer, which is the what? The 2 by 2. Now, this gives this is coming. Oh, good. That's fine. Your question is, how did they get the 2? If I understand you right, how they got the first 3 and the second 3, right? Hello, Joy?
Yes, correct.
So now, how did they get the 2? Now, I've always told you that every channel of the image comes with a channel of the weight, right? Good. So now this image is here, right? Now, those three on those channels of the image will give one output. Now, how many weights do we have? We have only 2 weight channels. So we have, this is one weight, where each of them has a weight channel for the 3 images, and we have another weight. So this one will give us one output, this one will give us another output. So if you look at where the green is, so it is on this weight right now. That's why it's generating this output, and then it will go to this weight to generate this output. So the number of weights, now the number of weight also comprises the channels, will tell you the number of outputs. Do you understand? Usually what I use, my own formula is that last part is the number of bias. So if you look at this weight comes with its bias, this weight comes with its bias. So the number of bias is usually number of weight channels. Now I know that's confusing. Don't worry. As we move on, it will make sense. So this is a useful resource just to read, understand the concept of padding, which is why everything has zeros, right? Concept of padding, pooling layer. We talked about max pooling, and we talked about average pooling. It's just along. These are state of the art convolutional neural networks, LeNet, AlexNet, GoogleNet, VGGNet. VGGNet is what we looked at, ResNet, and so on. Right? They will tell you the memory consequence, of what they mean by memory, stuff like that. So it's just something that you can read through. If you don't understand, please let me know. Right? So that's the boring part. Let's get our hands dirty. So we've done sklearn, copy of sklearn. Reconnect. Oof, my data has gone. So now we want to do a case study. Now, what's the case study? The case study is car identification. We have images of cars, and we want to be able to identify them. Identify them. So what's this telling us? It's saying that there are 7 cars. We have 7 cars, right? Audi, Hyundai, Scorpio, Rolls-Royce, Swift, Safari, and Toyota. We want to be able to identify them. Hold on, let's pause. This class is quiet today. Is either I'm exciting or you don't understand what I'm saying? So far, is it good? Are we good so far? Hope I'm not moving too fast. Is everybody?
You are going too fast.
Steven, you did not. Why did you say something? Why did I lose you?
Actually, it's not your fault. I'm actually on the way. Following on the road. That's why. But it's fine. I'm following anyway.
No problem. Aside anyone,
I'm just continue. I'm following.
No problem. Aside anyone driving on the road, at a party, an engagement, whoever is looking at the screen, please, I need feedback on, because the most important thing to me is that I am preaching, you are receiving the message, The field is very unfamiliar to me. I know. It was once unfamiliar to me, so I know how you feel. I just need to rewatch again. We'll be more on that. Yes, please. And like I said, the only time I see engagement from you guys is on Saturdays. That should change. We should, you people, I should be sleeping like this. When, this initiative started, I was like, my God, this is how my week will be. But you people just put me in retirement. I was expecting questions that will be thought-provoking, that I will go and read my book again. But, it's like only remember me on Saturdays. You will be remembering me every day. You'll be eating. Tolu said this, Tolu said that. Yes, I know. Yes, but that's why we give you 7 days breath. We give you a duration of 7 days breath to, digest, reconstruct, and then there are some weeks when we recap, we repeat, we do rewind, but you people don't seem to have questions. Well, that's by the way. Let's get our hands dirty. So what do? We come to Kaggle and then we download the data. They don't give us data, right? Thank God for them. They've given us the data. We download the data. We download the data. So I come here. I will come to upload. When I come to upload, I have the data already. So I come to upload. So this is they will give us as a zip file, or if they give you as an unzip file, if you want to use Google Colab, make sure you zip it. When you zip the file, upload it. It is better to upload zip files instead of folders. It just makes it look like it's updating one file. So you can see that it is uploading. You can see the blue tick on the down. It is uploading. Sorry. So it is uploading now. While it's uploading, any questions, please throw it at me. Let's wait. Let's what is it about convolution or about regression or about TensorFlow that you don't understand so far? Can you explain what each of those libraries do? Each of those libraries are machine learning libraries. TensorFlow is backed up by Google. sklearn is, then there's PyTorch. PyTorch is backed up by Facebook or Meta Group. sklearn, they all do kind of like the same thing, but with different algorithms. So the programmers of TensorFlow would have probably written a new way of writing. So it's just a way to compare model performances across different things written by great minds in the industry. Right? They all do the same thing. The sklearn or the regression done by TensorFlow is good, but if you check your model and you run it different times and you see that sklearn is giving you the right answer, use sklearn. So yes, time is up.
Hello, sir.
Stephen, please, let's hear you.
Okay. From what you just described for the last person that asked question, is that what we classify as a cross validation?
No.
Okay.
Every submodel has cross validation. I can do something on cross validation. I can do something. Okay, so okay, let's pause. We'll cross validation. Let me see if I can create. There's something I said I wanted to teach earlier that I forgot. If anybody can remind me. But let's just put it there. Cross validation. Cross validation means that your training data, you will split it into X number of validation sets, X number of independent validation sets. You pick random. This is batch 1, batch 2, batch 3, batch 4, batch 5. So you can train on 2 of those batches and you test on those 3, or you test on those 5, and you check their performance. That's what cross validation means. So now you cannot do cross validation on TensorFlow, cross validation on sklearn. You can, all of them have their own cross validation syntax or method of approaching things. Let me move this one. Yeah. So now, for, I don't know if it is Iniolua, someone asked question about if you download a folder from Kaggle, make sure you zip it or compress it, upload it to Google Colab. So this is what I have. You can see .zip. Now, now when you do this is the code to unzip. You can see what I did. I will just unzip car data set. It will unzip it for me, and when it will unzip it for me, it will create a data set for me. It will create the folder. It's working on it. Don't worry, it's working on it. It will create. You just see that the data will pop out now. So now, isn't that train split data? No, it is not train split data. It is not train split. So I'll come back to that question. So you can see the car data set is ready. We have car data sets. I don't like this. I don't like this. And, yeah. Mhm. Sorry. Okay. So that doesn't distract us. So what do I do? What do I do? What is the cocoa of what I'm doing? What's the cocoa of everything, right? So now I'm going to import relevant libraries. OS, I want to use TensorFlow, right? TensorFlow. Now, so what I did was I want to go to the library. So what does train dataset have? Train dataset has something called train. Car dataset has train and test. What does train have? Train has all the datasets I want to do. Now this is Audi, Hyundai, blah 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 blah. Now, in machine learning, there is something called labeling. There is something called the data set. You also have to label the data set. Now, hello? Steven, please mute your side. In machine learning, right, there is something called data set and labeling. Now, normally before some smart people sat down, right, and I did this in grad school, you would download an image and you say that this is if you want to do snake identification or car, like all these Audis, just imagine all these cars, right? All these cars. You can see that they are named randomly. You go and put Audi in all their names. You go and put Audi in all their names so that it will identify Audi, which using string manipulation. And see, if you see Audi in this name, in the name of this file, it is Audi. There was a function we wrote for that. Thank God I was a teaching assistant. I just told some of my undergrads to do it. So in on day, just look at all the images. You can on day. You understand? Rolls Royce, same thing. That was how people used to label. People came up with different methods to label. Right? That's how people used to label. But there's something called data augmentation function, which I will show you. So all you need to do is all the images, just put them in a folder. The name of that folder is going to be the label. Do you understand? That's how they labeled these images. You know, in our regression, they will label each column. Each row is a data. Each row is a data. Yeah, each picture is a data. But group of pictures are now given a class or a classification. So all the cars in this place are Audi cars, or they have Audi logos on them. All the cars in this place have on there. So just put all of them in one folder and name it that class. Please don't make sure when you're doing your data, don't go and put the image here inside here. Your model will be confused. Now, I've gone to read that data, right? Let me read so let's look at the image. So if you look at Audi has 1.jpg. Let us see what 1.jpg is. Because it's a car, I know it is what? Color. It's colored, right? So let's see what the car looks like. This is what the car looks like. Right? If we look at 1002, let's see what 1002 looks like. This is what it looks like, right? Audi, they are all Audi cars. 1005, they are all Audi cars. If you want to move away from Audi to go to Hyundai Creta, all right? If you want to go to Hyundai Creta, instead of Audi, I'll just change this to Hyundai Creta, and there is 1.jpg. If you want to look at Hyundai, this is what the car looks like. You can see that the environment is different. If you want to do 101, let's see what that is. Hyundai. You can even see that in these images, it's so dirty that there are people inside. there are people in the background. It's not clean, it's not the car alone. Because in real life, if you want to deploy this image in real life, different things will be in the environment. How will the conv layers, the pooling layers now go and attach distinctive features that in this image, I saw this image and they say it's on day. And this is another image. There's a human being here. They wrote on the image. They did this. What is common to those two? It will attach those features and be mapping. The more images is, that's why the more your data, the more intelligent it is, the more generalized it is. So when you are working on it, you can see all the, if you want to go through all the cars, you can see all the cars. Now, what is the size of the image? The size of the image is 168 by 300 by 3. So by 3 means it is a colored image, which means it is BGR or RGB, right? And it is 168 by 300. And I told you in machine learning, we usually put them in the same size. Normally, before we would have Ctrl F, wrote a function to go and shrink and resize all the image to the same size. But there's a function for that. And that function is image generator. Image generator. What image generator does is, it gives you, for example, look at this car. Imagine this car, right? Imagine you only take a camera or a picture of this car at this range, just at this range, and you train a model only at this range, at this distance from the car, right? When you give it a picture that was taken at this distance, it will be difficult for it to recognize. So you have to take the picture at this range, at this range, at this range, at that range, at different ranges, at different dimension. What if the car was turned upside down and given to the model? You understand? There are different things that can happen in the real world. You understand? It's just like face detect. If you do your face like this and your camera is looking, or you look upside down, your camera will still detect your face. Different things. You need to add as much randomness to your data as to mimic the real world as possible. So that is what this image generator does for you. These are all the things it can do for you. You can rescale it. Rescale is usually advised. So rescale is, instead of it to be 0 to 255, it will be 0 to 1. So we'll divide everything by 255. We'll divide every pixel value by 255. That's what rescale means. Rotation range. Rotation range means rotate it by what degree? So this image now, this function will randomly go and take images and rotate them by this, rotate it like this, rotate it like this. So rotation range, I'm saying rotate range for about 40 degrees. So rotate it to about 40 degrees. So and the camera validation split. I'm saying that of these trained data sets, 0.2 should be for validation. Can you hear me? You just showed the notification that loss of connection. Can everybody hear me? Hello?
Okay, yeah, you're fine.
Thank you.
Okay, you're fine.
Yes, width shift range. Shift the range by some width. Just instead of you to start from here, looking from here, shift it by some range. Just basically, what if I can't see, if this is the image, what if I can only see this part? Height shift range, what if I can only see this part? It's just adding some perturbation that, what if this? So it will go to some random images. Instead of it to see the complete image, it will slice up some parts and see some parts. Zoom range, that means it will zoom into the image by 20% and see it from close range. It will zoom out by 20% and see it from far range. I've forgotten what shear range means. Horizontal flip. Flip the image horizontally. Flip it. Just flip it horizontally randomly. It's not going to do that for every image. You just go to this image. Let me flip it. This image. Let me zoom it. This image. Let me zoom and flip. This image. Let me this. Let me that. Right. So all these are things you can play with, right? Just to make sure your data is as robust as real world. So what do you do once you create that? Just create something called, using the image generator class, create a data generator function. That data generation function is that, rescale it, rotate it, and split it into validation. Now, I directed it. Now, what will this do? Target size. This will automatically resize all the images to 100 by 100. That's just that one line. It will make it so the image that is 168 by 300, it will change everything to 100 by, well, no matter the size. If I change this thing to 1, right? If I change it to 1, look at the size. You see that the size will change. 301. The previous one was 300. It will change everything to 100 by 100. It will zoom it. That's all it is. Life is now easier by far. So that's basically what it's doing. And then what is it telling us? It's telling us that in the train, so if you look at, there are two directories. In the train data set, there are 3,352 images overall, and they belong to 7 classes. So now, in the test image, there are 813 images overall that belong to 7 classes. Make sense? So now, I now want to use TensorFlow. TensorFlow, I'll use a sequential layer. Now, the sequential layer, what is the input it's taking in? It's taking in an image of 3 by 3. It's taking in an image because it's colored of 3 by 3. The image size is 100 by 100 by 3, right? Because it has resized it. 100 by 100 by 3. Now, it's going to pass it through convolution layer. We all know what convolution does. Convolution filters and shrinks with a window. So it's going to take in an image of 100 by 100 by 3. And what is it going to output? It's going to output, it's going to convolve with 3 by 3. What's the output shape? The output shape, TensorFlow did not give us. The output shape is going to be 100 minus 3. Now, here we did not say stride. We did not, if not, there's a place where you put stride. Stride by default will be 1. 100 minus 3 divided by 1 plus 1. 100 minus 3 divided by 1 plus 1. 100 minus 3 is what? 90 what? 97 plus 1. So I'm going to get an image of 98 by 98. Now, what's the third one? You notice when we were talking, Joy asked a question that, okay, where is that thing? Okay, we have 7 by 7, we have 3 by 3. I showed you that I minus k over x plus 1 will give you the first 3 by 3. How do we know the last one? This is 3 by 3 by 3, 3 by 3 by 3. But this is giving me 3 by 3 by 2. Why is it 3 by 3 by 2? Because the total number of weights is 2 weights. That's why we are getting 3 by 3 by 2. In this place, the way TensorFlow did it, it is 32. That's what is there, the number of outputs. So you are going to get 98 by 98 by 32. Sense? Similarly, max pooling. Max pooling will come here. Max pooling will take that output of 98 by 98. You are going to do max pooling with 2 by 2. So in this case, it's going to be what? With pooling, it's going to be what? 98 minus 2 over 1 plus 1. 98 minus 2 is what? 98. 98 minus 2 is what? 96. 90. No, I think I'm saying something wrong. 96. I think the stride here is 2, but we'll come back to it. So basically, this is how to slit. I was just trying to tell you what the parameter. Activation is ReLU. What ReLU means is that there will be no negative number. If a number is negative, it will be 0. It will only take 0 to positive numbers. And that's what this place is telling us, that if you look at the activation layer here, ReLU is always, if it is negative, it will be 0 to only take positive numbers, right? So if your output is -5, 8, 2, it will be 0, 8, 2. Now, once we do that, this is our model summary. Our model summary, can you see? More way. 98 by 98 by 32. The pooling part, sorry. These 2 means window and 2 means stride. So it's going to be divided by 2. 98 minus 2 is what? 96. 96 divided by 2 is what? 48. 48 plus 1 is what? 49. Is what? 49. Then you do the convolution. It will take 49 again. Subtract it by 3 divided by 2 by 64. Then do the pooling again. right? So now that is going to give us the, so we know how they got these sizes. If it's that you are doing exam, the question I will have set for you. So we know how they got all these sizes, right? We know how they got all these sizes from pulling. That's what I just wanted to derive for you. Now, this is the model parameters. Overall, these model parameters is 2.6 million. What does it mean? What does it mean to you? You that are just using your iPhone or your Android. What does it mean to you? It means that the memory requirement to save this model on your phone or on your device or on your Raspberry Pi, where you will at the site of deployment, is that all these weights will be saved as float data type. Float data type. You know, we did it in the first one. Float, integer. You know, float data type. Float data type is 32 bits. The memory computation, the ones and zeros, you know, computer language is in ones and zeros, right? Is 32 bits. Now, 4 bits makes 1 byte. To convert it to bits, I will multiply it by 32. To convert it to bytes, I will divide it by 4. So that means that all this is 2 blah 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 bytes. So this model is 20.9 megabytes. 20.9 megabytes is the size of a short movie. That's the size of the model. So this model is an overkill. To me, it's an overkill because you're just identifying 7 classes. But I just wanted to show you the relevance and significance of when you are doing your model, space should be, you know, very important to you as a machine learning engineer. So I pick my optimizer. So this is categorical cross entropy. There's binary cross entropy if it's just 2 classes. Categorical if it's more. When I pick my optimizer, there's RMS drop. We can do Adam, right? We can import Adam here. So RMS drop. We should talk more on that. Let's run all these other ones. Yeah, I've done something wrong. What is going on? Okay. I'll do this and I'll do this. Yep, we're back in business. I'll do this and I'll do this. And then organize your journey. So now the next thing is to train our model. So if you see this train generator, I already have it here. I did it from a train generator. It has gone to my data, pick my data set, squeeze everything into 100 by 100. It has done all this. Train generator is coming from train data gen. What is train data gen doing? Is rescaling all the image, rotating it, zooming in, zooming out, all those things that I will have done manually. If I show you some of my notebooks manually, is all, you know, automated, right? So life is just getting better. This is the best time to be a student. I will not read and I will pass, right? And then voila, we are training a model to identify cars. Now, why this project was of interest to me was back in school, we did a project to identify car make, you know, car type. So that means that if a car is a convertible, if a car is a coupe, if a car is an SUV, and then we went on the road, we put it with camera. We went on the road and cars were passing, you know, and it was identifying it in milliseconds. It was identifying based on the number of car. How many on this road or coupe? So now you can see the accuracy is growing, the loss is so. Now someone asked the question the last time that when you are doing TensorFlow program, this is example what your playground is doing. Your TensorFlow, this is what it's doing in the back. This is what it's doing in the back. It's training, it's calling all these libraries and pinning all those things and attaching weights. So it is doing all these weights. You can see that after 5 rounds, right? The first round was 20% correct. Now it is 32% correct. So it's still going, it's going to 100. So this is like giving it examples and classwork just for it to get its understanding, right? So it is going, it is 3 seconds per epoch, right? If I want to increase it, so you can see here, I changed steps per epoch is 8. That's why this is 8/8. if I remove it, it's going to be something different. It's going to be something, you can see it's 27 by 27, but it's going to take longer time. So you know that one was 3 seconds. So this is just a way to optimize your training time. These are just hyperparameter. It doesn't change anything. You can see that the starting accuracy then was 20. This was 27, but it will still get to the same point, right? So this is 10 seconds instead of 3 seconds per training session. So that means that for this training to be done, it should take 1,000 seconds because I'm doing it 100 times, right? So that's some of the things you take into consideration when you are training. Like for me now, if I'll just train sharp with 5 steps per epoch, see that the model is doing well. If the model is doing well, I can just go home, turn the training overnight and go home or go and sleep, maybe using the maximum steps per epoch. So yes, we are here now. It is training. Why it is training? Any questions? I know you should have a lot. Any questions? Thank you. No questions.
Don't go.
Quite a number of stuff on the plate. God help us. See, let me tell you something. If
Okay,
I can
hello.
do, yes, Stephen.
Okay, the truth is the information today
It's too much.
so
Too much. I know. I was.
really
That's
touch a
how.
lot of things.
Yes, but I'm counting on you, and you, my very responsible student. So please just go back, look through it, message me on Google. I'm here for you. That's why I'm here. Message me on Google. Say this part it doesn't make sense. I read on Google or I asked ChatGPT. ChatGPT said this is it. So and then we'll talk you through. But nobody.
Okay, do we have another class? Do we have another class after this?
No, Google Classroom is here. Google Classroom is always on. It's here.
No, I mean, another meeting like this. This is the 8th class, right?
Yes. So
This is
yes,
actually my first live class.
this is the 8th class, but we would have to discuss. So the foundation is going to discuss sometime in the background to see where we are, what we think we have, and I personally think I want next class to be an open breakout room. Everybody, I'll give all of you questions and all of you will come back with answers for me. I just want to know what's the accuracy of your model and you display it, and it will be a 15-minute exercise. That's what I want to do, and I will know who has been reading and who has not been reading.
Okay, actually, this is actually my first live class.
And don't
yes,
worry, we have videos. Imagine I'm live.
We always attend at the American corner.
Okay.
We are always attend there. I just say, okay, this whole season will not just come. Season 1 will not just come and go without me attending live. That's why I'm here.
That means you are very lucky because you have Mr. Israel right there in person.
Yes. He has been. No challenge. I do that. He knows. He will tell you. So he would have told you. I disturb him a lot.
You are tapping from the fruit of knowledge.
Thank you so much. Please, if there's another class, we will appreciate, sir. Thank you so much.
No problem. No, like I said, the foundation will talk in background where we are now, what is going on. And please, your feedback too is good. Go on, give us feedback what you think we can do better. Because we are here for you, right? And the goal is, that as much people as we can replicate this knowledge in, and even be better than us, is what we want. That's the goal. So yes, that's the goal. So as much as possible, if one additional class would be what would make that dream come true, yeah, why not? All right. So we're going to evaluate what we have and then see what we can do. Right.
Thank you.
So it is training, please, model. It was 84%. This thing wants to get A. He wants to get A. All right. Any other questions? Any other questions? just to say, if I tell you my path to engineering, to software engineering, it was a bit confusing, to machine learning. And we just validates the fact that if I can do it, I can assure you anybody can do it. I'm not lying. Right? Anybody can do it. Right? While it seems like a lot, right? It's not, it just takes practice. Download that. And you know the annoying thing there is that all this code is reusable. I have a friend that works for 3 companies and he writes the same code for them. The same code, and they are paying him 3 big salaries. 3 big salaries. It's just the same code. So if I go to an office now and they give me classification, you already have what to do. It's just that you need to know what each thing means. That's all. You already have what to do. Do you get what I'm saying? You can just take this code. You understand what it's saying, but you already have it. If you want regression, you already have it. Do you understand what I'm saying?
Hello, sir.
Yes.
Yes. Okay. I actually came with a question.
Okay,
The main question I wanted to ask today is in terms of the industry. Exactly. Is this with the exercise we are doing now? Is it the format it comes? Is this what we're going to deploy? Save this model and deploy in a production environment? That's one.
Yes.
And secondly, that's one. And secondly, for some of us who are, most of the jobs I see on LinkedIn with respect to machine learning, they usually require a background, at least a 3-year experience in software engineering. How does that affect people like?
How do they know you have 3 year experience? How do they know? It's what you tell them. How do they know? Wait, how many years experience do you have in software engineering?
Not much.
How many years? Quantify it.
I won't count it. I wouldn't even say 1 year.
You won't say 1 year.
I was
So
never
you have like 2-3 months or 4 months or 5 months.
Yeah, something like that. Yeah.
Okay, good. Now the next question is, I'm assuring you that if your resume is up to par, just submit your resume. However way it is, if it is up to par and that's the relevant talent, they would reach out to you. Now you want to tell me that someone that has 2 months experience in software engineering, answer all the questions, write all the code, and someone that has 3 years experience did not do as good as you that have 1 month, they won't hire you. They would hire you. So don't think about the job description now. That's not your problem. Do you understand? You just boost your skills and know that if anybody asks you anything, you're a principal in what they're asking. That's it. Because I can tell you that was one thing that used to stop me. And then all of a sudden, it doesn't matter. I just know that my resume is the best that any machine will see. And bam, that should not stop you. Get to that interview spot, submit it. All those things, they say it for submit it.
So we shouldn't say we should CV pad. Is that what you're saying?
You should what?
CV pad.
No, I'm not saying pad the CV. I'm saying get the skill. Once you have the skill, using the same idea as you. Get the skill. Once you have the skill, right? I have 5 minutes. Get the skill. Once you have the skill, write it in your resume and apply. Don't go and look at all those this thing. See, especially American companies or European companies, they are very objective. It's not Nigeria that they will say you must be male, you must be female. Once they see that you have it, they will invite you for an interview. If you can do what they say you want, nobody cares.
All right. Thank you so much, sir. I appreciate it.
No problem. Nothing should stop you in this world. So yes, our model is done. After 100 epochs, our accuracy is 95%. Voila. Voila. So let's test it. So what it's going to do is that I'm going to go through. Now, this is what it means. Now, there are 7 classes. What those 7 classes mean? Is that where it sees Audi, the first folder it sees, where it sees Audi, is going to say that it is 0. It's going to say this is 1. It's going to say this is 2. It's going to say this is 3. It's going to say this is 4. This is 5. And this is 6. That's how it's going to label it. To convert all those words to numbers. Now, let me look at Audi. I'm going to go through Audi folder. So I'm going to go through Audi folder. That means that most of what I'm seeing, most of all the images I'm seeing, you should give me 0. But it's 95% accurate. You get some things wrong, but you should give me 0, Abby. Let me see. Print Audi. Right? Now you can see something. Okay, yes, let me show you. Let me show you this. Yes, this. That's important to visualize it. Now, how is the model knowing that it's Audi? It's just saying it's Audi, it's showing 0. What does that mean? This is what it means. This is what that value means. It means that if you look at the model we created, in the model we created, we said that, oh, okay, you're going to predict 7 things. Those 7 things tally with these 7 things. That means that if predict 7 numbers, those 7 numbers tally with 7 probabilities. Now, if the probability of the highest out of the 7 numbers, if the probability of the highest number is the first one, is Audi. It based on how these folders are arranged. If the probability of the second one is the highest, that means it's on day, the third one, the fourth one, in this order. So now, what am I doing? I told this model in this function, I told this model that, okay, take the image, convert it to 100 by 100. When you convert it to 100 by 100, pass it through the model. Let the model predict, and I'll put all the 7 probabilities. When it does that, let me see the highest. So I'm not saying that what is the number with the highest argument. What is the number with the highest argument? If the number with the highest argument is 0, that means you should print Audi. Right? Now, in some cases, this is 0, Audi, 0, Audi. It means this one wrong. Your model is not perfect. Audi, it means this one wrong again. It means this one wrong. He said this one is 4. 0, 1, 2, 3, 4. He's saying this one and he's saying Swift. So if you look at the probability, this is 86. What is Swift? Swift is 98. He's saying that he's 98% sure that it is what? Swift. So that's wrong. This one is saying he's 99% sure it's on day, but most of the time it is correct. Audi. That's hence 95%. Now, if we say we want to do Toyota Innova, let's just go through the thing now. Let's go through Toyota Innova. Right? So if you see, it's 7 classes, that's 0 to 6, right? So you can see it. Oh, I didn't change this one. 6. Let's go. So you can see it saying Toyota Innova. In some cases, it's getting it wrong, but I'm sure it is 95% correct. Do you understand? So what I will now do is, in my office, I'll take this to marketing. I'll say the model is 95% correct. I tested it 100 images. 7 is wrong. Can you come? Do you approve it? Most of the time, 95% is actually a good result. Cool. So this is where we are now. Now we've done classification, we've done regression. We've done classification and we've done regression. I want you all to, go through the notebooks, see what we have. Next week, we'll do a lot of question and answer, probably recap, and then see what we can further add to our knowledge. So for any questions, I will just have time to take one question. Any question? I'm sure some people are still in shock. They don't know what just happened. We trained the model and we've tested the model. Right? So please rewatch the videos. There are a lot of cues that we've put there. Please, Mr. Israel, are you here?
Yeah, so sorry, I had a brief network disruption.
No problem.
I'm back now.
Yes, so me and Mr. Israel will consult each other and see how we can go on. Because I was supposed to take 4 lecture series. Next week will be supposed to be my last, but we're going to see and re-strategize and see what we have and what we can do based on your feedback. Your feedback will help us to tailor your needs, to tailor our approach to your needs, right? So please go through the notebooks. This is probably, right now, if you can do convolution in the hierarchy of machine learning engineering, you are on number 5. If you can understand regression and convolution, you are number 5. What is left is NLP, transformers, and generative. Oton. Any machine learning engineer in Japan cannot top where you are. So that's that. I'm sorry I have to go and cut this session short. I have to jump into another meeting as soon as possible. Thank you all. Let me know if you have any questions. The lecture notes will be popped up on the Google Classrooms. And if you have any issues, there's a Wednesday class. You can join in and see, if that will add more to your knowledge. Thank you. Take care of yourself. I will see you later. So I'm going to stop recording now. Can I? Okay.